Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to speak about the SAAG classification of ascites. What is SAAG classification of ascites? It is a very common terminology and we hear it every day. SAAG is the abbreviation of the serum ascites albumin gradient, SAAG. It is a very simple formula, and as we can understand, it is a gradient, not an equation. It is a gradient. It is used to assist in determining the etiologic causative of ascites. This formula of the gradient is simply the subtraction of the ascites albumin from the serum albumin. So it is a serum ascites albumin gradient. Serum albumin minus the ascites albumin. Why is this phenomenon? It is according to the stalling forces between the fluid of the circulatory system and the acidic fluid. Under normal circumstances, the difference between the serum albumin and the ascites albumin would not be very big. It would be less than 1.1 because the serum oncotic pressure, which is pulling the fluid back into the circulation, usually is countering the balance by the serum hydrostatic pressure, which is pushing the fluid out of the circulatory system. This balance is disturbed in certain diseases like liver cirrhosis, heart failure, Budd-Chiari syndrome, where the hydrostatic pressure is increased markedly on the expense of no difference in the oncotic pressure. So the fluid that is going to get out of the circulation is going to be much less than that is coming back again to the circulation. So the accumulation of fluid inside the peritoneal cavity will be increasing. But the SAG subsequently will increase because there is more fluid leaving the circulation, and the concentration of the serum albumin will increase. Albumin does not move across the membrane, so the albumin in the circulation will be kept, while the albumin in the ascites fluid will be less. It is not going to travel with the fluid that's going to travel to the peritoneum. That's why the gradient will increase and the difference will be more than 1.1. In rare causes where elevated SAG without change of hydrostatic and osmotic pressure is when we bring to the peritoneum a fluid that is devoid of albumin by itself without any change of the hydrostatic pressure. For example, when a urinary bladder ruptures, it will leak urine into the peritoneal cavity, and we all know that urine is void of albumin, so the SAG will increase, but without change of hydrostatic. This is the understanding of it. After that is going to be the application. The application that high gradient SAG, where the difference is more than 1.1, which means that the gap between hydrostatic and oncotic pressure is high, indicates usually portal hypertension and suggesting a non-peritoneal cause of ascites. A low gradient increased non-portal hypertension and usually suggests peritoneal causes of ascites. This is the simple information. These are examples of high SAG like liver cirrhosis, fulminant hepatic failure, liver mets, Budd-Chiari, portal vein thrombus, veno-occlusive, myxedema, heart failure, constrictive pericarditis, pulmonary hypertension. All of them usually increase hydrostatic pressure. And low SAG like malignancy, peritoneal carcinomatosis, nephropathy, where we lose already albumin, and similarly malnutrition and the protein losing nephropathy. That's why they have low SAG, because already the serum albumin will be low and there will be loss of albumin in the whatever the place. Tuberculous peritonitis, pancreatic ascites, serositis, and secondary peritonitis. Okay, to create an algorithmic simplified approach, we might add total total protein in the acidic fluid to minimize even this into where the acidic protein is less than 2.5, which means that the acidic protein is low. So those are in cases of cirrhosis and late Budd-Chiari syndrome and massive liver mets, where the ascites protein is low. So this is a capillarized sinusoidal hypertension. And those with higher acetic protein, where the acetic protein is okay, like the post-sinusoidal hypertension, where there is a normal sinusoid, but they are leaking, like congestive heart failure, constrictive breathitis, early cases of bad carry, IVC obstruction, or sinusoidal obstruction. So these are the two sides of a high SAG, and of course, low SAG, like we said, like biliary leakage, nephrotic syndrome, pancreatitis, peritoneal carcinomatosis, and tuberculosis. This video and others are going to be present on my YouTube channel. Thank you very much.